Every Queensland State primary school receives Advancing STEM funding to lift student outcomes in science, technology, engineering and mathematics. Schools are developing strategic plans to prioritise their STEM improvement initiatives. These plans respond to the local context, are informed by evidence and meet the needs of their learners. We're visiting Heatley State School in North Queensland region to understand and learn from their STEM improvement journey.
So back in the day, Heatley was one of the largest schools in Queensland, but now our enrolment is sitting just under 500 students. We have 21 classes from prep to year 6, and about 45% of our students come from Aboriginal and Torres Strait Islander backgrounds, and as well we have a considerable number of students born overseas from New Zealand and Pacific nations, Malaysia, the Philippines and some African countries. So we've been working in STEM for about 7 years now in different shapes and forms. So I'm really committed to the work that we have started because I can really see the difference it makes to students' engagement and learning. STEM has and will remain a significant piece of our work in this school, and it will retain a budget line in all of our strategic planning that I can see into the future.
North Queensland region uses the School Improvement Model's inquiry cycle and aligns this to the 8 Steps of Collaborative Inquiry by Lynn Sharrett. Regional officers support schools to collaboratively plan how to wrap an inquiry process around an improvement focus. Heatley State School has undertaken a number of cycles of inquiry in science, technologies and mathematics to build the critical and creative thinking skills of their students. This story will show their journey using collaboration, evidence and an iterative approach to refine their improvement initiative. Now they're ready to hand over to an emerging leader to scale up what's working. Let's look at some of the evidence they used in their initiative.
So our STEM improvement journey has really been about future-proofing our teachers and our students. So we realise that the world as learners is going to be changing. So we want to provide opportunities to make sure we're all ready for that. And that just coincided with the department's STEM initiatives, and we were part of the STEM cluster trial, and then we were able to use the Advancing STEM funds to help support those opportunities. We also considered the fact that our teachers were used to starting their maths lessons with modelling, but looking at the gradual release of responsibility and wanting to perhaps start at the independent level to engage the students more in their learning. And some of the teachers were quite honest that they were used to being in control of the learning in the classroom, but knew that that mightn't be where they wanted to always be. So that led to wanting to find out more about inquiry-based learning, and the teachers wanting to know, what does this look like at our school?
Yeah, and there were flags in the school's NAPLAN numeracy data as well. So in measurement and geometry, only 14% of the Year 5 cohort got the question correct on analysing angles in complex shapes. And in actual fact, the whole Year 5 cohort across the nation found this very challenging, with only 20% of students getting this one correct.
So prioritising the mathematics curriculum, we identified 2 problems of practice. The first one was, how are we going to develop teacher confidence in using inquiries, pedagogies in maths? And the other problem of practice was, how are we going to change teachers' mindset about how to implement assessment and move away from always modelling their thinking to their students? We sought the advice of our regional STEM champ, Marie, to help us move the work forward.
Yeah, so my role was to gather the research that would help to identify our next steps or inform what approach we were going to take that would address our problem of practice. So we were already familiar with visible learning for literacy, so I looked at visible learning for mathematics by Fisher, Frey and Hattie, which looks at the different phases of learning, going from surface to deep and into that transfer phase of learning. Hattie also lists Piagetian programs as an effect size of 1.28. So knowing that Piagetian programs focus on thinking skills, this was really reaffirming for what we were considering. We also referred to the National STEM School Education Strategy, which states that STEM is the collection of learning areas or disciplines connected by common thinking skills. These are critical and creative thinking, design and innovation, collaboration and communication, and problem solving. And of course, we referred to the department's STEM in Queensland State School's key messages advice that reminded us that if we were using a cross-disciplinary approach, mapping to the curriculum is essential. We also recognise that applying a cross-disciplinary approach and bringing in the thinking and digital technologies into their mathematics lessons would enable this transference of learning. The STEM Connections project, which is detailed on the Australian Curriculum website, also has some very useful resources to help plan for applying a cross-disciplinary approach. So exploring this research, we were able to then collaboratively plan what our next steps would be in order to improve student engagement, problem solving, and critical and creative thinking skills in mathematics and digital technologies. So we recognised that the best way to build teacher confidence in planning an inquiry approach in measurement and geometry was going to be for us to model this. So teachers were invited to create a maze using a range of angles and lines. They had to program a robot through the maze. They started working independently and then they went to shared and guided. This encouraged teachers to identify what they needed to know in order to solve this problem. So I became the facilitator of the learning, empowering teachers as learners to collaborate and use critical and creative thinking to solve the problem, as well as engaging with new ICT tools. So QR codes were progressively put up around the room to differentiate the learning and provide multiple ways to access the required support. So we collected evidence of impact along the way by referring to the guiding questions on the State School's improvement strategy. We also end up looking at the 5 questions for teachers and 5 questions for students by Lynn Sharrett. But we also added in the 5 questions for system leaders as well as 5 questions for middle leaders, because in our region we've contextualised it to include all parties involved in the improvement focus, just to enable that precision in our piece of work.
The students were really passionate about the learning that they undertook in this unit. They wrote persuasive letters in their English unit to the principal to ask for a school set of Spheros because we'd been borrowing the regional ones.
So our improvement focus has been refined over multiple iterations. When we sat down to review the work, it became really apparent of the evidence of impact. Teachers' confidence had improved greatly with applying and using an inquiry approach in the classrooms, in their mathematics lessons, and also our students' learning outcomes had improved, and they felt much more confident in using problem solving and critical creative thinking skills when they were analysing angles in complex shapes.
We have collected the evidence we need to be confident in upscaling this approach across our school. So now I'll be handing over the leadership of the project to Nicole, who's been integral in the project's success so far.
In the future, it looks like expanding across years 4, 5 and 6, starting with year 5, looking at upskilling the new teachers to that year level this year. We're also looking at introducing microbits in science in year 6 later on this year. The next thing we will do is to identify and then develop further cross-curricular STEM learning opportunities in both years 4 and 6. To ensure the sustainability of this work, flexibility and consistent collaborative professionalism is absolutely vital.
In this approach to STEM school improvement, we see why Heatley State School is confident they're scaling up the right work. The right work has strong connections to student needs and is aligned to the Australian curriculum, high leverage practices and system priorities. We identify the right work when we use evidence to plan, implement and monitor. And we do the right work through intentional collaboration. How do you know what's working to lift student outcomes for your students? And what does scaling up look like in your school?